Hello! So for my first milestone project for our geology class, we are talking about a mineral that is important to our home communities, and so I decided to talk about quartz. I'm from Madison, Wisconsin, and I'm considering the broader upper Midwest my home community. I was born and raised there, and I'm a big fan. But quartz. Quartz is also known as silicon dioxide. It's one of the most abundant minerals in the Earth's crust, but this doesn't make it uninteresting to study. It's important to my home community because we have a really massive quartz deposit that's made up of really pure quartz called St. Peter's sandstone. And it's a prime example of quartz mineral deposits in the US and the world. And so I thought that I didn't have any quartz before starting this project available to show, but I've learned that silica sand, which is made of the mineral quartz, is used for making glass. And so here's some glass from my mason jar, and it's partially made up of quartz. So I did end up having this mineral on hand, which is exciting to learn. Before diving into Wisconsin's unique quartz context, let's talk about what this mineral actually is. Quartz is made up of silica, which is made up of silicon and oxygen, the two most abundant elements in the Earth's crust. Quartz belongs to the mineral group silicate, which at least our textbook describes to be the most important mineral group because it comprises most of the Earth's crust and mantle. Quartz is made up of silicon dioxide, and it has a framework atomic structure. This framework structure means that there are no clean cleavage planes within the atomic structure, and so quartz does not have any cleanly cut, organized fracture points. Instead, it fractures conchoidally. Quartz has a vitreous or glassy luster, resists weathering for very long periods of time, and it has a hardness of 7, which means that it can scratch glass. It has a rough fractured base, but like the face of the quartz where the crystal grows is usually smooth and well developed. One of the tricky things about quartz is that it can appear as many different colors. The purest forms of quartz, which are found in Wisconsin in St. Peter's sandstone, are clear, but quartz can be different colors depending on impurities and elements that bind within the silica structure. So for example, iron, sodium, magnesium, potassium, calcium, and aluminum are all common elements that will bond within the silicon structures, and these affect the color, so that might make them look pinkish or grayish, even sometimes bluish. So trying to identify quartz by its color oftentimes just doesn't work out. In general, quartz is usually used as a filler material in paints, paper, vitamins, even foods. But in Wisconsin's context, because it is so pure, the mineral is oftentimes used for glass making or for creating fracking instruments to access natural gas and oil. So quartz can form a number of different ways. As one of the most common minerals, it's really abundant across the world. So one of the most common ways that quartz can form is through magmatic formation, where felsic, silica-rich magma and lava flows and cools in plutons. So quartz is the last mineral to crystallize and the first to melt, according to Bowen's reaction series, which this means that quartz is the last thing to solidify in plutonic settings and magmatic chambers. And so it fills in the gaps of a lot of the other minerals that have already crystallized. And we saw this with granite's composition in class. So for this project, I read a research paper by Clark Johnson and Bryce Winter, and they cite a lot of their work from A. Tyler, who did work in the 1930s, looking at St. Peter sandstone in Wisconsin and Michigan. And these scholars found that the quartz was derived from Precambrian basement terrains, which I learned are fragmented blocks of crust, of like the Earth's crust. And so they found that the geological setting of this region is sedimentary rather than magmatic or igneous. They asserted that the Precambrian Great Lakes region was a topographic high and the ultimate source of sediment throughout the Paleozoic era. And there was a lot of durable quartz grains in this area, which endured multiple sedimentary cycles, suggesting that the quartz in St. Peter sandstone underwent a sedimentary formation. But how did this quartz actually arrive in this region? So one explanation I found was that around 2.5 to 3 billion years ago, during the era of the Precambrian Shield and the Canadian Shield Craton, there were ancient volcanoes that brought felsic magmas up that created these magmas, and then throughout time, throughout the mid-continental rift system and the Ice Age, this quartz did not weather, but surrounding materials did, and so then this quartz was left over, and then it was eventually compressed by multiple sedimentary systems, and now we have the pure quartz that we have today. Interestingly, the upper Midwest, including Wisconsin, is currently in a geological period of isostatic rebound, which means that this region is rising, which I didn't know about, because the crust beneath the Great Lakes, which was once, continually weighed down by glaciers, is now experiencing the opposite situation, and so the land is rising, and so some areas around the Great Lakes, specifically Lake Superior, are gaining in elevation today. As for how plate tectonics and mineral resources influence my home community, Wisconsin has a few inactive fault systems beneath the surface, but it's generally far away from subduction zones, from divergent zones, convergent zones, really plate interactions. So it's also far from volcanoes, and it almost never experiences earthquakes. And when earthquakes are felt in Wisconsin, which are very rare, only every few years, if not decades, they usually come from earthquakes in Illinois or Michigan or neighboring states. However, this is very rare. With that being said, Wisconsin, as it is very cold, it can experience cryogenic earthquakes, which are related to the ground freezing and unfreezing or melting suddenly. And so these earthquakes are not necessarily related to deep tectonic forces in the Earth's crust, and they rarely cause damage. They're only felt a few hundred yards of a radius, and they occur sporadically, so they have not been able to be studied very much. They're also called ice quakes, and this especially happens in the area where I'm from, where we have a lot of lakes, and so when lakes crack, this also causes, a big boom, and the ground kind of shakes, especially if you live close to the lakes. As for how mineral resources influence my home community, the quartz that I've been talking about today is used for glass making, but also for fracking, which, it contributes to climate change, but it also is an industry that it's also an industry that provides a lot of people with livelihoods. There's a lot of gas and energy companies based in Madison. I'm specifically thinking of Madison Gas and Electric, MG&E. So this affects my home community because it creates a job market. And quartz makes this possible because it enables fracking materials to be made, and then the extraction of resources to occur. Additionally, I didn't talk about these other mineral resources, but the Midwest is a big agricultural area, and so we have really mineral-rich soils largely from glacial melting and glacial deposits. So growing up, I had known that there was a lot of quartz in Wisconsin. I remember, always asking my mom, like, oh, what is this rock? What is this rock? And 9 times out of 10, the shiny, pretty rocks I picked up would be quartz. And so I knew that there was a lot of that around, but I didn't necessarily know the history or the uses for quartz. That was definitely a mystery. Even when I was looking up, if there was anything in my dorm room that was made of quartz or had quartz as a mineral inside of it, I was surprised to see that glass is made up of silica, which is quartz. And so a lot of this project was new to me. It was really cool to learn about the background behind quartz in my community, especially because, when I was younger, I was curious about, oh, these pretty rocks, what are they? And so to learn that they have a deeper purpose within society, and also that they have a rich history spanning back billions and billions of years. And we really have a unique, very pure sandstone deposit in my area. That was cool to learn about, and I didn't know about that before. And so I'm very grateful to have done this project and learned about quartz and sandstone in my hometown. You can consider this my formal AI statement. The only thing that I used AI for was when I Googled if there was quartz in mason jars. The little Google AI automatic thing popped up and said yes, and so that informed this project for a little bit, but I did not use AI in any other part.